Hello and welcome. Today we're going to do a deep dive on the Porsche 992 911 Gt3 Rs Aerodynamics. Let's get into it. In this video we will explore the importance of aerodynamics, the various aspects of aerodynamic design, and how Porsche has reconciled seemingly opposing objectives to optimize the performance and drivability of this high-performance sports car. Aerodynamics is essential for achieving high speeds, driving stability, safety, and energy efficiency. The new Gt3 Rs takes road car aerodynamics into a completely new sphere. Porsche has never put so much effort into the development of a GT sports car. With over 1,500 simulations and with over 250 hours in the wind tunnel, they've been able to achieve a new level of performance. They've doubled the downforce compared to its predecessor, and compared to the GT3, it's even been tripled. This radical change in downforce is due to the front packaging. The 3 radiator concept is now a mono concept, just like the uncompromising Gt3 R race car. For the first time in Porsche's road car history, they have a front wing that's fully active and infinitely adjustable. The front flap can be rotated by more than 80 degrees, and this can be done in just 0.3 of a second. By rotating the flap in higher downforce position, they achieve the highest downforce configuration, and the downforce on the front axle is increased to the maximum. Porsche needed to increase the venting of the wheelhouse. The traditional louver outlet on the top of the fenders was not enough anymore. A new passage for the air behind the front wheels was designed to increase the venting. Even the door design was affected by it. On the Gt3 Rs, not only does it have directional vanes on the underbody, they also feature on the roof. When the hot air exits the front radiator, it would just flow over the top of the roof and the engine air would be affected by it. So Porsche has developed a new hood outlet that pushes the air to the sides, and the roof fins continue this work and keep the hot air on an outward direction. The rear wing is of course huge. It's made of a fixed main blade and then a movable secondary flap. Together with the active system on the front, you can reduce the drag by nearly 30%. When you press the DRS button, DRS drag reduction system, the car turns the flaps into a low downforce position and the car achieves the lowest downforce possible. The new Gt3 Rs is really a new milestone in road car aerodynamics. The combination of these two new aero systems, front and rear, gives you the perfect aero balance and perfect aero setup for every position on the racetrack. One of the most important steps in realizing a significant increase in downforce on the front axle is the shifting of the radiators. The S-duct layout has its origins in aviation and has been used in racing series such as Formula 1 for a number of years. The maximum dynamic pressure on the vehicle is used to achieve the highest possible airflow rate at the radiator via the central opening in the front section. At the same time, downforce is produced by deflecting the air upward. Now let's hand over to Jörg Bergmeister to talk us through the new controls on the steering wheel.
We're sitting in the new Gt3 Rs. The current Gt3 already set a really high bar in terms of balance with its double wishbone front axle, but the new Gt3 Rs is a whole nother level. The car with that much downforce usually is really sensitive to right height changes, especially under braking. The front usually gains a lot of downforce. But we made a change to the front geometry and put more anti-dive in it, and that gives us a more equal aero load under braking as well and keeps the balance consistent. So usually to change the damper settings you need a mechanic, but with our new steering wheel it's just a press of a button and you can adjust compression and rebound, front and rear axle while driving. And it's a really big tool for a driver. You can adjust the car perfectly to any racetrack or tire conditions. So for instance, on a really bumpy track, you can go a little softer on the overall damping, or if you're on a really smooth track or have plenty of grip from brand new tires, for instance, you can go a little stiffer overall. So basically it's a race car driver's dream come true. Also on the steering wheel, one of my favorite features is an adjustable differential. For instance, when you're struggling with a little nervous rear on corner entry, you can add some more differential on coast, or if you're struggling with oversteer on the corner exit, you just tighten the diff up on power a bit. So it's a really big tool. Also, when your tires degrade a bit, you can adjust the car really nicely with it. Yeah, so far you could either turn the traction control on or off, but now it's really cool. Just like in the race car, we have a fully adjustable traction control with 7 positions, and you can still switch it off just to your liking. Yeah, all this makes it the best handling 911 road car ever on a racetrack. It's so much fun, especially in the high-speed corners. The performance of the car is just amazing, and I'm sure you're gonna have as much fun with it as I do.
But Porsche is not new to aerodynamics. The list of legendary milestones is therefore long. Here's a selection of the most important milestones. At number 1, beginning in 1975 with the 911 Turbo, also internally referred to as the 930, was the first production sports car at Porsche to feature a large fixed rear spoiler with ventilation slots and a rubber lip. The feature ensures clean air circulation, controlled air capture, increased downforce, reduced lift at the rear wheels. Thanks to its sophisticated aerodynamics, the 911 Turbo was Germany's fastest sports car for a long time when it came to top speed. And then in 1985, the Porsche 959 is characterized by an aerodynamically optimized body. The rear wing is integrated into the exterior of the body. The super sports car is also equipped with automatic height adjustment and aerodynamic plastic underbody paneling, which also allows it to remain stable on the road up to a maximum speed of 315 kilometers an hour. And now the 956 from 1982. The aerodynamically sophisticated body of the 956 is legendary. In combination with the aerodynamic underbody tunnels, the super race car features a downforce of over 800 kilograms, thanks to the ground effects and low vehicle weight of just over 800 kilograms. It could theoretically drive on the ceiling when reaching a speed of 321.4 kilometers an hour. But the top speed of the 956 was 350 kilometers an hour. Which brings us to 2003 and the Carrera GT. With its carbon fiber full underbody paneling, rear diffuser, and electronically extendable rear wing, the Carrera GT generates downforce that comes close to that of a race car. The rear wing automatically raises when reaching a speed of 120 kilometers an hour and can be controlled at any time with the touch of a button. This ensures for higher downforce at the rear axle, which has a positive impact on driving stability, even at the top speed of 330 kilometers an hour. Moving to 2013, the 918 Spider features active aerodynamics. Included are an adjustable rear wing and rear spoiler for quick and precise adjustment of the different downforce levels at the rear axle. Active diffusers in the front underbody paneling for high downforce at the front axle, a completely enclosed underbody for low air resistance, and adjustable cooling air flaps in the front that reduce air resistance when closed and provide cooling when open for high performance. The 2015 911 Turbo S. A special feature of this car is the pneumatically extendable front spoiler for more downforce on the front axle at high speeds. In combination with its flexible and highly durable base material, the front spoiler offers a high degree of variability and low risk of damage. Just a quick note to say that we are a printed magazine. If you love the analog medium, check us out on the website. I'm Lee from Duck and Whale. We'll see you next time.